The issue is, red dwarfs are a lot cooler. Like, they're still really hot, so, like, don't touch it. But, Alright, what's up, guys? It's Sarcastic Dragon here. This is my second attempt at an intro. So anyways, welcome back to Space Engine. Not Space Engineers, Space Engine. People got that mixed up last time. But, anyways, so in the last episode, I manually found our planet from the other end of the universe, because this is like a 3D map of the universe. Or I attempted to do that, and I say attempted mostly just because I want to say that I succeeded, because I did. I was proud of myself. It's pretty great. Anywho, we're gonna go back through today. I am not gonna do that again. Okay, all right. You know what? Yeah, no, we're already out here. I'll do it real quick, okay? I'm 5 billion light years away. That ain't right. You are M87, which means you are the Milky Way. So now, don't go shooting past it. So now, you right around there. What are you? I think I've seen you before. There you are, Karine. Hey, there's that thing. Which means that you're right there, which means the Pleiades are somewhere in this general vicinity. I'm facing right side up, so that's good. Let me align my... I gotta align myself with the disc here. Okay. Alright, so you're right here. Pleiades, you're somewhere right there. So now, we need to turn face this way. Find the Hyades real quick. Hyades, dude, I give up on that one. Alright. Aldebaran is somewhere in there, right there. And so now here's my new frame of reference, right? I just gotta get up close to it. Slow down. Alright. So now, I gotta align myself up so I'm kind of like on the plane of the galactic disk now. The small Magellanic Cloud, which keeps unrendering, needs to be directly below pretty much directly below. That's close enough. And so now if I look up this way, then I can see this Antares Nebula, which means Sirius is right there, which means that the sun is right here. No, I'm not looking. I don't want to see the SS Science. I want to see the sun. Solar system. Boom. Alright, and I mean, from that point on, you know I can just find the planet. So that's good enough. Alright, cool. That's how we're opening the episode. Took me 30 minutes to get that back down, but, anywho, so, we're just gonna explore some of the cool stuff in the universe. We're gonna start with Hoag's object? Hoag's object. Go. Yeah, there we go. Go to that. Now, this is a ring galaxy. And it looks really weird. I mean, that's all I've got for it, really. It just looks really cool. It actually looks cooler if you look at actual pictures of it. This isn't as good a render of it. But, anywho, no one understands how this galaxy was created yet. We can't figure it out. We'll get there, though. So, let's go to M87 next. I mentioned this in the last episode, but we'll go over it again real quick. All right, Messier. No, what do you... Wait, Methuselah. Wait, that's a planet. Wait, where's the Methuselah star? I don't know. We'll check it. Look at you. Frozen gas giant. Oh, is this around a pulsar? Where's its star? It's over there. Ah! Right? White dwarf. You sure these aren't pulsars? They look like pulsars. They're very bright. Neutron Star. Yeah. That's a white dwarf. Okay. Alright, I won't question that. So this must have been one of the earlier stars found. This might actually be one of the first planets that was ever found. Back in the 90s, I think, that we found orbiting a pulsar. A pulsar is a neutron star, and a neutron star is weird. So basically what happens, right, is you got a big star. Big star, way bigger than our sun. It goes boom, but it's not quite large enough to become a black hole. So what happens is it becomes a neutron star. Now, okay, we can't see it. You can see them you can get a better look at them in Universe Sandbox, but I'm not going to switch games over for that. So basically, they rotate, like, really fast, like thousands of times per second fast, and they do it at such a regular interval that they're almost, I think they're actually better at it than our atomic clocks are. So, if you've ever seen that disc of the Voyager probe that's supposed to be, like, for aliens if they ever find it, there's, like, a bunch of lines on it, and what that is that's a map that shows a bunch of different pulsars relative to where our sun is, and that's supposed to be kind of a map to where the sun is in the galaxy. I think. Don't quote me on any of this, alright? But I'm pretty sure that's how it works. Next up, let's find UY Scuti. Oh, okay. No, this is the right one, I think. It's just abbreviating them. Yeah! So this is the largest star in the known universe. There's a difference between largest and most massive. Most massive means it has the most amount of stuff in it. This is just, like, largest in terms of volume, but it doesn't have as much stuff in it. And what it is it's a red supergiant, which means that it's about to die. And when I say about, I mean within probably the next few million years. It's got 6 planets, does it actually? Woof. That's rough. What about you? What are you? Oh, you're a planet. Scorched ice giant. I'm not sure those two words line up. But we'll take a look here. Are these all the planets? Oh, it has moons. Okay, I don't think these are real. We've only found, like, one exomoon, because those are really hard to see. I don't think this is correct. But, yeah. So this is, I believe the sun... Actually, wait, can I place a sun down here? I don't know if this is portraying the size correctly. It's a big star, okay? That's all you need to know. So next is VY Canis Majoris, which is the second largest star in the known universe. It looks about the same. Oh, I know. Boomerang Nebula. Yeah, let's go to you. Okay, so this is the Boomerang Nebula. So when a star dies, not necessarily with a supernova, but more like our sun will, it just kind of sheds off its gas. That's what this is. What makes this one special is it is the coldest place in the known universe. Coldest, not oldest. Coldest with a C. Like, chilly. It's like 1 degree above absolute zero. Actually, it's not the coldest place in the known universe. That was actually in some lab in, like, California or something like that, where they got it down to, like, a few billionths of a degree above absolute zero. So actually, the coldest and hottest places in the known universe ever were actually in laboratories on Earth, not in space. So that's kind of cool, right? Anywho, or at least at that given moment. I mean, at the beginning of the universe, stuff was way hotter, but not colder. So anyways, yeah. That's about all that's special about it. It's just really cold there. So, this is a dying star. It's a very massive star, so it's not as, like, big in terms of, like, diameter as, the UY Scuti one that I showed a little bit ago. But this star, it's very massive, and it's gonna blow up very soon. And again, when I say very soon, I mean probably in the next few thousand years. And how far is it from Earth? Let's see here. Sun. If I just click on the sun real quick. Okay, so it's about 8,000 light years away. So when it blows up, it's not going to be a big deal. But that also means it could have blown up to about 7,400 years ago, and we wouldn't know yet. Because light got to travel to us. So we see how the star, how it was 7,400 years ago. So it hasn't... So if it blew up less than 7,400 years ago, then we wouldn't have seen it yet. So it might already be gone, but we don't know. Yeah, it's going to be a very big supernova. Like, big enough that it'll be, like, I think somewhere around the brightness of the moon. If you go to Australia, it'll be, like, about as bright as the moon. So that'll be pretty cool. Definitely go there if you're still alive at that point. It's got about 300 solar masses. Right, did I click on the right one? 125 solar masses. What was that one next to it? There was one that says 300. What's the most massive star? Actually, I think the most massive star is smaller than that, isn't it? It's like 250 or something. Hang on. R136A1. Okay, let's see here. R136A1. There we are. Let's find you. Oh, it's in the... Oh, it's not even in our galaxy. 265 solar masses. Okay, so where's that 300 one coming from? Okay, so this is the most massive star in this, in the known universe, not in the galaxy, because I actually didn't... I thought it was in our galaxy. It's not. It's in the... This is a smaller, large Magellanic Cloud. This is a large Magellanic Cloud. So this is a satellite galaxy. It's the largest galaxy that's really close to us. It's irregular, which means it doesn't really have a shape. And then there's also the small Magellanic Cloud, which is just kind of down there. There's actually a lot of dwarf galaxies around our galaxy. Here's another one, the Draco Dwarf, which appears to be maybe elliptical, but I don't know if dwarf galaxies really get that classification. They don't get a whole lot of attention. And here's another one, Ursa Minor Dwarf. There's another one that's somewhere along the plane here that's basically invisible, and I think we determined that's basically because it's made almost entirely of dark matter. Okay, quick aside. Hit the brakes. So, just today, you'll be seeing this tomorrow. So, today, June 14th, 2019, apparently there's new findings that suggest that this galaxy does not actually exist. So, yeah, disregard this whole part about the dark matter galaxy. That's the theory, at least, last time I checked. But it's somewhere along this, and it was almost impossible to see. In fact, I'm not even sure if it's in this. Okay, so out here... Oh, we never looked at M87, did we? I said we were going to do that. Why? Oh, is it case sensitive? No, wait. Oh, is it space? Oh, it's a space. There's a space. M87. So, this is a very large galaxy. I don't remember how many stars it has, but it's a lot larger than ours, I can tell you that much. It's one of the largest stars we know of. Largest stars, largest galaxies we know of. Did I... Oh, okay, it's a galaxy, not a star. But in the very center here, if we can get there. See the creamy center? No, I passed through it. Okay, all right. Well, the black hole at the center of this galaxy, because every large galaxy has a giant black hole, and I mean giant, like billions of times the mass of our sun, which means, like, it's like, I think this one is 40 billion, so take 40 billion suns, crush it together into a black hole. There you go. You got this one. And this black hole is the one that got its picture taken. You know the one. Yeah, that one. Yeah, that's like word for word what I said last episode. But you know the one I'm talking about. It crashed. There's another... This... No, you... So this is the Coma supercluster, right? No, maybe it's this. One of these is the Coma supercluster. The only reason it's important is because it's like the only supercluster I can really find in Space Simulator. Somewhere around here is the Shapley supercluster. Oh no, this is the Coma supercluster right here. Yeah. And then somewhere in this general vicinity is what's supposed to be the Shapley supercluster, but it does not really appear to be in the game right now. And it's like the largest supercluster that we know of, or one of the largest at least, and it's pulling us and all the other galaxies towards it, and that's believed to be the source of the Great Attractor, if you've heard of it. That mysterious thing that's pulling all the galaxies towards it. It's probably that. Another interesting fact is maybe, this is a very controversial idea, but maybe it's just cool to think about, it's something called dark flow, and that's the idea that it seems that all of the galaxies in the entire universe are moving in one direction, like something's pulling it, and what that might be is that there's a much denser area of the universe that we can no longer see because it's expanded so much that we just can't see it anymore, or that it's so far away that we can't see it anymore. But at the beginning of the universe, it was still connected to us gravitationally, so it's still moving in that direction a little bit. But that may or may not be true, and it's just a cool thing to think about. It's something that, like, I don't know. It's an idea that a lot of scientists don't agree with. Look, I'm no expert, okay? I just think it's a cool thing to think about. But don't go around stating that as fact, because it's not. It might be, but it might not be. So, yeah. Anywho, next up, what's next? Oh, I know. I see 1101, or 1001. Now this, you don't. That's not right. Yeah, that looks more correct. This is the, I think, hang on, okay, I'm gonna Google it, just make sure I got the numbers right. Okay, yeah, okay, so it's 1101, not 1001. This is the largest galaxy in the known universe. That's about all I've got to say about it. It also probably has one of the largest black holes in the universe just because of how large it is, but I've looked it up before and I can't seem to find an exact figure on that. So, speaking of biggest black holes, let's see if we can find it. Ton 6 something. Okay, they don't have it here. Oh, let's go to TRAPPIST-1 while we're at it, since that's right here. Go to. So, what's special about a little TRAPPIST-1 here? Well, it has 7 Earth-like planets, 2 of which were in the habitable zone, but we're not really thinking that there's anything here because, as far as life goes, because the issue is red dwarfs are a lot cooler. Like, they're still really hot, so, like, don't touch it. But, they're a lot cooler than our sun, and so that means in order for it to be in the habitable zone, a planet to be in the habitable zone as far as temperature goes, it has to be closer. And the issue with that is that these stars like to shoot off a lot of radiation. I mean, our sun does too, but I think red dwarfs do it a lot more, and so that's just not very good for life. So there's, I don't know. It doesn't look good, but I mean, who knows? So, anyways, but believe it or did I get stuck inside of it? Can I get off, please? Okay. All right. Anyways, let's see here. As far as what could support life, you would assume that our sun, yellow dwarfs can support life. We know because if you look up in the sky, there's one doing it right now. But there might actually be a type of star that's better at it than we are, and it's called an orange dwarf. And I mean, I don't really, I'm not sure if I can actually just find one. I mean, I saw one when I was looking for. I saw one when I was looking for the sun. But basically, they're just like, they're kind of in between red dwarfs and yellow dwarfs. That's, they live longer than the sun, and I think they're kind of more stable. So they might actually be better for life than our sun is. So, anyways, yeah. I wonder if there's like an updated version of Space Engine that I just don't have. I was going to do Ultima Thule, which, the New Horizons probe passed recently. It looks like kind of like a peanut, or like a snowman. Yes, it looks more like a snowman with like two, just like one big rock and then a low rock that's just lightly attached to it, and it's like the farthest thing away that a solar or that a probe has ever visited in our solar system. So, I wonder if we can find Halley's Comet. I mean, that doesn't really need a whole lot of introduction, I'd assume, but just see it to see it. Is that what it looks like? Wait a minute. That looks like Ultima Thule. I mean, the neck on Ultima Thule is smaller. Is that really what Halley's Comet looks like? Okay, then. So this is an ocean planet. We found it back in 2006, 2008, somewhere around that time, and everyone freaked out because it's very Earth-like. But, like, at least as far as, like, size goes and stuff, and it's probably just a lot of oceans. Am I underwater? I go underwater? I think I went underwater. Probably get out of there. Out we come. Oh! So, like, ideally, this is what maybe a water planet looks like, except it would look like our sky. Not, like, because there's, wait, am I on the... No, I'm not on the night side. So imagine just a calm, temperate day over the ocean. Ocean as far as you can see, really pretty and stuff. That might be what these planets are kind of like. Maybe. Not maybe this one in particular, but there might be some that are like that. Temperature 153 degrees Celsius. Not great, which means it must have a thicker atmosphere if it's going to hold onto the liquid water. I don't know. Discovery date, oh, was it 2011? Okay then. 33B. Ah, yeah, here we are. Go to. So this planet, we get onto the... Oh, is this another one of those really dark planets? It must be. This is HD 189733B. It is not a nice place. Its main, you know, kind of selling point is that it rains glass sideways because the wind is so strong that it... So yeah, rains glass sideways. Not a place you want to be. Next up, Wasp. Yeah, it's 12B. Wasp 12B. This is a fun one. It's not portrayed very accurately in this one because it's actually egg-shaped. Because it's so close to its star that the star is, like, ripping it apart. It's also blacker than asphalt. So, that's also not exactly right because it's not very dark here. It's pretty bright. But, yeah. Oh. Yeah, it is Enceladus. Okay, alright. That's around Saturn. Okay, alright, so this is Europa. What makes this special is it's probably the place in the solar system where you're most likely to find life. I mean, you know, other than Earth, obviously. But, there's a few reasons for that. One, it has an underground ocean. I think that's confirmed at this point. It seems to have all the right ingredients for life. That's a bit strange. That's not right. But anyways, it has all the right ingredients for life, it seems like. And, I don't know. I'm not really... I haven't studied up on it a whole lot. I need to do that. But if you're interested, go look at that. But, something interesting is these red cracks, these stains, in the ice. To my knowledge, nobody really knows why they're red. But one of the proposed, and again, I'm not saying that this is what it is, because it might not be. It may totally not be aliens, and if it is, it's probably microbial. So like, don't go around saying, okay, look, I'm not saying anything, but I'm just putting this out there. One of the theories is that this red staining is caused by microbial life that are kind of like getting up close to the surface, and if you go to Enceladus, which is around Saturn, Enceladus is a very similar body. It also is believed to have all the right stuff for life. And it even has all the same cracks that Europa has. There's one difference, though. The cracks aren't stained red. So if these two bodies are so similar, then why does Europa have red staining and this one not? Again, not saying it's aliens. It may totally not be. But it's just something to think about, right? We're on the surface of Venus. Hot desert. That's a bit of an understatement. So, why is Venus so terrible? Well, let's start with the fact that it's hot enough to melt lead, famously. The other thing is that the atmosphere is made up of sulfuric acid, and it's also about, I think, 90 times thicker than Earth at the surface. Oh yeah, 92 atmospheric pressure. Yeah, it's not, the atmosphere is 92 times thicker than Earth. So if you were standing on the surface, it would basically be like if you were on Earth, but you were a kilometer underwater. And if you were a kilometer underwater without, like, a really expensive submarine, it's just gonna crush you. So, if you walked out on this planet, you would be dissolved by acid, crushed to death by the pressure, and then burnt from the heat. Okay, there's a black hole around here somewhere. And it's pretty big. It's not as big as the one that we took the picture of, but it's pretty big. Where's 273? You got 278, but not 273? I don't even know what's special about 278. (3C273) is a quasar. That one is not a quasar. Why is that in there, but not 3C273? It's got 3C278. What is special about... Why does that bother me? It bothers me a lot. What about... Wait, 3C179. There's 3C178, but it doesn't have 3C179. Why? Ooh, wait. What about Shabilskis? I don't know how to spell that. I doubt it's in there. Okay, I think I'm going to cut the episode here, so I'm not pushing any buttons. Alright, I guess we're going off into the void. Alright, we're at 12.5 billion light years away. We're getting to the point where we can't see much. But anyway, I mean, like in real... Okay, anyways, forget what I said. So if you're interested in a lot of this stuff, I'll put some of my favorite astronomy videos from channels like PBS SpaceTime, which I recommend that, especially if you want to see about the quasars and the neutron stars and stuff like that. It goes really in-depth on that stuff. Anton Petrov is another one. I'll put links to in the description to a few of the channels that I learned a lot of this stuff from. But thank you guys so much for watching this video. If you liked it, maybe click subscribe or comment, or like it or comment and say, Sarcastic Dragon, you fucked up your outro. How many times have you done that by now? And I mean a lot of times, but like, I don't know. So anyways, thank you guys so much for watching this video, and I will see you guys next time. Peace out.